This is a lesson for the second day for Division Properties of Exponents, Chapter 7, Section 4. Let's take a look at our first problem here. And it asks us to simplify this expression. So when we've got the negative exponent on the outside of a parenthesis, we're going to multiply the exponents inside the parenthesis by the one outside. So it becomes 4 to the negative second over 7 to the negative second. Well, I don't want to multiply out the 4's because I've got the negative exponent. So in order to simplify this, I need to take the reciprocal of any negative exponents that I have. So it becomes 7 to the second over 4 to the second. And then multiply them out, and I get 49 over 16. Looking at the next one, same sort of thing. This time we have more parts to it. So if you don't see any exponents on bases, put 1 as the exponent and multiply those exponents. So I still have the negative sign inside the parentheses. And now it becomes, and I need to put it inside the parentheses, so negative sign there. And then I've got 3 to the negative third, x to the negative 12th. So I multiplied the exponents. And I do the same thing in the denominator. So 2 to the negative third power and y to the negative 15th. So now I'm going to go ahead and take the reciprocal of any negative exponents. And so I still have that negative sign there. And it becomes 2 to the third power. And then I have y to the 15th. Those are both on top because they were down below with negative exponents. The 3 to the negative third goes to the bottom. It becomes positive, or 3 to the positive third power, and x to the positive 12th. So I can go ahead and multiply out the 2's, and that leaves me with 8y to the 15th. And then down below I have 27x to the 12th. And I still have that negative sign there. It did not cancel out. And so I had even or an odd number of numbers that I was multiplying, and it was a negative 1 being multiplied, so it doesn't change anything. So it's still going to end up being a negative number. An odd number of negatives makes a negative. So I look at the next one, and I can reduce this fraction a bit first before I go ahead and multiply. It'll make the problem easier. So I'm going to take out the common factor of 3 from both the 12 and the 15. And so that leaves me with 4 over 5. And now I'm going to subtract the exponents there. So I have 3 halves minus 1 over 1, which is the same thing as 2 over 2. So I just made that 1 into a fraction, which I could go ahead and do the subtraction with. And I still have this all raised to the 4th power. So that makes 4/5. And I've got p to the 1/2 power. And then this is all to the 4th power. So now I'm going to go ahead and multiply out those exponents. Again, 1 is the exponent if you don't see an exponent on a base. And I have 4 to the 4th, and then p to the 2nd. Half of 4 makes 2, and then 5 to the 4th power. So I could go ahead and multiply out those 4's, and 4 times 4 times 4 is 64 times by another 4. And that makes 16, carry a 1, that makes 256. So I get 256 p to the 2nd all over 625. That's what that ends up being. So looking at the next one, the same thing. So put exponents of 1 if you don't see them. And we go ahead and multiply out the exponents. I get a to the negative 2nd, b to the negative 6th. And down below, I've got a to the 5th times negative 2 makes negative 10, and b to the negative 2nd. Now, I wasn't very wise here. I should have reduced this. It would have made it a whole lot easier. I'm going to show you how it ends up being the same with this problem. So notice that I've got more a's on top. This is a bigger number, so they're going to be on top. And it should be that way when we do the subtraction. That's something you should check for. So I'm going to subtract the negative 10 and then do the same thing here. B to the negative 6 minus negative 2. So I'll add the opposites, and I'm left with an a to the 8th and then b to the negative 4th power. And when I go ahead and take the reciprocal, you'll see how I'm left with a to the 8th all over b to the 4th power. And that would end up being the answer. Now check it out. It would be the same thing if I had reduced it to start with. See how I have more b's on top, so it would be b to the 2nd power, and then down below I'd have a to the 4th power. And then when I go ahead and multiply those exponents, I'd end up with b to the negative 4th, and I end up having an a to the negative 8th. You take the reciprocal, and you see you get the same thing, a to the 8th over b to the 4th. So make sure that you reduce the fraction in the first place. It'll make the problem easier at the end. But you'll get the same answer no matter which way you do it. And that's what I'm going to do here. I'm going to reduce the x's first. I'm going to take out this x and take 1 away from this from the numerator there, so I have 3x now, and I still have the y to the 5th, but there's some z's, and you see how these are negative z's here? I'm going to move those down below, and that becomes z to the 7th power down below, because I added the 5 and the 2. So now I'm going to bring everything to the negative 3rd power. So I'll go ahead and multiply out the exponents, so 3 to the negative 3rd, x to the negative 3rd, y to the negative 15th. Down below, we have a z to the negative 21st. So now I'll go ahead and take the reciprocal again of numbers, and so I have z to the 21st, 3 to the 3rd power, x to the 3rd, and y to the 15th. So all I need to do now is multiply out those 3's. So I'm left with z to the 21st power all over 27, x to the 3rd, y to the 15th power. That would be our answer there. So let's take a look at the last one here. It looks like we've got some multiplication we could do first, and I'm going to go ahead and do that. I got 12m squared n to the 5th. So I went ahead and added up any exponents I could, but there are none because we had m's and n's, which are different. But I did have 4 and 3 I could multiply to make 12. Here I have negative 2, because the negative 1 here multiplied by 2. And I got some m's. I've got m to the negative 2nd. Well, how did I get that? Because the 1 here, oops, actually I see this 3 here, so let's go ahead and fix that. And I'll go ahead and multiply out these m's. So I've got m to the, I'm going to go ahead and fix it from this point. I'm going to erase what I did here and multiply out these m's in this section. So I've still got this 2m to the negative 3rd, but I'm going to go ahead and distribute the exponent of 3 over. So I've got negative 1 to the 3rd, and then I've got the m to the 3rd and n to the 3rd. So now I can go ahead and combine some like terms down in the denominator. I still have that 12, and it's m squared n to the 5th, and then down below I still have the 2 times by negative 1, because negative 1, negative 1, negative 1 multiply to make a negative 1, and then I got some m's. Well, these 3 m's here are going to cancel out the 3 m's here, so all I'm left with is n to the 3rd power. And so now I can go ahead and do some reducing. So think about what's left over here. So this makes negative 2, and when I divide it into 12, I get negative 6. And then I still have the m squared, but I have n squared on top, and that's it. So notice how negative numbers we don't take the reciprocal, only negative exponents. So let's take a look at the next set of directions that we might end up seeing being a little different. It says explain why each expression is not in simplest form. So what we want to do here is simplest form means that we have positive exponents, no 0 is an exponent, and any numbers that we have that are bases, go ahead and multiply out. So this makes 16r to the 3rd, and that would be in simplest form. So here we have this extra set of parentheses. So let's go ahead and multiply out that exponent by each of the exponents in this problem, which are 1's in this case, so 3 squared x squared. And so from there I could multiply out the 3 squared to make 9x squared. So taking a look at the next one, the part that's not simplified is this right here, n to the 0. This equals 1. So it's just m to the 3rd times by 1, which is just m to the 3rd power. And the next one, well, there's 2 bases that are the same, so I could go ahead and use the division property of exponents, and I'm left with subtracting those exponents to make y to the 4th power. So those are the types of problems that you'll see on your homework. Good luck.